All right. Hello, everyone. I'm back with the next lesson in the LRC Python code course. And in this lesson, I'm going to show you how you guys can take the system check program that we just made and how you can then manipulate that by adding some lines of code and changing some things to make a new program in which there will be two buttons that appear, one of which is a correct answer and one of which is an incorrect answer. And if we have time, I'll even show you how we can maybe do a reversal learning task where those two are, they'll switch every 10 trials or something like that. So we can see how maybe we want to test reversal learning in a task like that. If we have time, that might be another lesson, we'll see. But yeah, the reason I wanted to do this is I sort of wanted to reveal one of the spoilers of coding monkey programs, which is that oftentimes when you want to code a new monkey program, it's easy to just go ahead and take a task that you've made previously and just modify some of its structure and its code to get the program you want. And so if you take something that's really similar, I mean, it's really not that difficult. And I'm going to show you how to do that today. I've done no preparation for this lesson. I'm just going to literally walk you through the systemcheck.py file that we made in the last lesson. And I'm going to show you how you can just easily change things to make a new program. And so, yeah, this is what I typically do when it comes to a monkey program. And honestly, that's why when I say you can pretty much make any program once you know how to do a delayed match to sample, which we'll get to in future lessons. And so once you have that code, you can kind of manipulate it and modify it in any way you want to sort of make any program that you could possibly need. Now, there's obviously nuance to that, and there's some complicated functions that you may need to know for certain things, but that all comes with experience, and I'm always more than willing to help you answer or help answer those and guide you through them. But yeah, so we'll go and get started. So I went ahead and opened up the systemcheck.py file. This is also the same as the student copy. You'll notice they're the exact same, except for one exception, which is we have a title up here. We're calling this program right or wrong because there will be one answer that's right and one answer that's wrong. And that's the only thing that's different about it is I've went ahead and changed this title so that I didn't get them mixed up. So if we go scroll down here, we'll go down to our trial classes, where we're going to need to make some changes. Now, before we begin, it's important to think about what exactly is the right or wrong doing differently than the system check, right? And so it's important to think about a task from its structure before we go ahead and move into its sort of whatchamacallit, into actually writing down the code. And so if you think about what the system check program was, it was, you hit a start button and then an icon appeared. And then if you clicked that icon, you got a pellet, right? And so that's the system check. But if we want to do a right or wrong program, right, we have sort of the same steps, right? We need to hit a start button. We need to hit an icon. And then that's when the program sort of is going to break into two different branches, right? You're going to have one branch where if they click the right button, it's going to give them a pellet and the right sound. And then the other one is going to be if you hit it, you get a buzzer sound and you don't get a pellet, right? And so that's sort of where the program's going to branch away. But for the most part, it has the same phases, right? A start phase, an appearance of the stimuli phase, and then once the button's clicked, you get your reward or not. So we don't need to do anything with the phases. We can keep our phases the exact same. Instead, what we want to do is first, we want to make sure that we can have an incorrect button appear. And so in the zip file that you downloaded for system check, you should have noticed that there was a PNG in here called Incorrect.py. We're just going to call that, and that's going to be our other object. Now, you can make this look any way you like. You could change its appearance, whatever. But for the sake of this, we're going to do a red button, which the male monkeys, which is interesting, probably wouldn't be able to see the difference between the green and the red buttons. But we as humans, unless you're red-green colorblind, will be able to notice the difference between the green and red button. So we're going to use that for the sake of simplicity. Now, what we need to do is we actually already have that incorrect.png loaded in as an icon. And so if we go down to the function within the trial class at right here in the create stimuli function, you'll see that our list of icons is has three components: the start button, the green correct button, and the red incorrect button. And so we already sort of expedited that process and included that in there in the last step. But if you didn't have that, all you would do is you would just add this in here, right? You would add that it's an icon with the PNG of being called Incorrect.py. And then you would add it into this self.stimuli right here at icons2. Whereas previously the system check could run with just that. Now we need to add this second one in there. And here we have the start button, the correct button, and the incorrect button. So there we go. Now we have the incorrect button. It's loaded into the trial or into the trial class. So now when a trial runs, we need to now draw that, right? And so if we jump down here to the draw stimuli function right here, just a couple lines down at line 264, you'll see that we're only drawing one stimuli. We're drawing stimuli at the 1 position, and we're moving it to position equals 0. Now, what you'll see is if we just simply change this to, so we'll run it real quick just to show you what happens, right? So we run and we hit the start button, and then what happens? We get the green icon appearing, right? But now, if we just change this to a 2, self.stimuli at the 2 position, move the screen and draw it on the screen, it should draw a red button, right? And so just by changing those 2 numbers, we were able to change the button from green to red. But that's not going to help us at all, right? We need to be able to draw both buttons on the screen at the same time. So in order to do that, let's go back to what our original code was. These are 1s. Goodness, I cannot type. All right. Honestly, you can just copy and paste this. You just go like this, copy that down, put it in the next 2 lines, and change these to 2s. So if we run it like that, you're going to see we still have a bit of a problem. There's still only 1 button being drawn. And the reason that is because we did not modify the position at which it was being drawn. So you'll notice that when we move the stimuli 2 to the position, we're moving it to the same position as stimuli 1. They're both located at icon position at spot 0. Right? And remember, we defined these icon positions earlier right here. Self.icon position is at line 181, and we have them at 1, 2, 3, 4 possibilities of options. We have a top left, a top right, a bottom left, and a bottom right. And so what we need to do is we just need to simply change that number in the draw stimuli. So maybe we want to draw it at icon position 1, right? And now if we run it, we'll see that it creates 2 different icons at 2 different positions. Now, it works great if I hit the green button, right? So we now have 2 buttons drawn on the screen, but now what happens when I hit the red button? Absolutely nothing. The cursor just goes behind the object and it's not doing anything because we haven't told it to do anything. So now we have the buttons being drawn at one of the 2 locations around the 4 corners of the screen. So now what we need to do is make it so that the program actually does something when we touch that button. Oops. So where do we go to do that? Well, we jump down here to the run trial function, where the trial is actually running. This is where we previously defined how the program should respond when it collides with the green button right here, and that is right here. If cursor collides with list, self.stimuli equals 1. That's basically saying if the cursor collides with an item in this list that is equal to 1, aka the green button, then what we're going to do is we're going to write in the data file, we're going to make the sounds that true sound, we're going to dispense a pellet, we're going to increase the number of correct, and we're going to end the trial, right? So theoretically, what we can actually just do is we can copy this whole thing right here, and instead of an if statement, what we're going to do is called an else if statement. Let me get rid of that real quick. And an else if statement is basically within that sort of loop of statements, and it's going to check for a different condition. So in this one, we're saying if it hits stimuli number 1, do this. Otherwise, else if, E-L-I-F, otherwise, if it collides with stimuli 2, which is now the red button, we're going to do whatever follows. So in this case, let's just leave it as is. In this case, we're just going to make a program that's basically a system check, but you got two different buttons. So go ahead and save that and run it this way. All right, so if we hit the start button, now if we hit the red button, you'll see that it makes the correct sound and also, once again, dispenses a pellet. So that is showing that it is correct. So now our program's actually doing something, right? So just real quick, we've changed maybe like 3 lines of code, and we already have a program that now has 2 buttons instead of 1, and the buttons look different and they appear on different locations of the screen. Now, we wanted the program to actually run, right? So instead, we're going to have it, if it collides with stimuli 2, we're going to have it play the false sound, which is that buzz sound. And then we're going to actually have it not dispense a pellet because they got it wrong. So they don't deserve a pellet on that trial. And so we're just going to get rid of that line. And then we're also going to say that their correct they didn't get it right. So we're going to remove that. And one thing that we're actually going to do is currently we have an ITI of 1 second or 5 seconds, something really small. But maybe we want to have them have a timeout whenever they get it wrong. So instead, what we can do is let's make sure that we have timeout defined. Here we do, it's timeout. It's from the parameters file. And so instead we can do timeout, which I'll need to check to make sure it's actually different. So let's go to the parameters.txt file and change the timeout. It was a little bit different, but let's just change it to 10 seconds, right? So there's 10 seconds there. Close out of that parameters file and go back to the script here. So now if they get it wrong, they're going to get the buzzer sound. They're not going to get a pellet. They're not going to increase their number of correct trials. And they're going to actually get a timeout of 10 seconds rather than the ITI of 1 second. So let's go ahead and run it and see what happens. As you see, hit the start button. If we hit the green button, we get the pellet over here. We see a pellet was dispensed. And we get that ding sound. But now, if we hit the red button, let's see what happens. So we get the buzzer sound, and you'll notice that we're now on a timeout. This trial has not restarted. It's been more than 1 second. We're counting down. Anytime now, boom, there's our timeout is over, and we can move on to the next trial. So just like that, literally, I think we changed maybe 10 lines of code max, copied and pasted a couple things, right? And just like that, we made a whole new program. Now, I did forget, we do need to change one thing, and this is always the last thing I change. We need to make this, this is the self.write file, so this is what's going to write it into the data file, which we went over in the previous lesson. But you'll notice here that this actually needs to be changed to a 0 because their data file needs to say that they got the trial wrong. Right? If we leave that as a 1, it's going to, in the data file, it'll say that the monkey got it right when in actuality they didn't. So we need to make sure we change that just because the write function, which is literally right here, needs that input of whether the trial was correct or not. So yeah, that is literally all that there is to it. It is simply just copying and pasting and changing things. You'll see in the next one when we do the delay match to sample that there will be some structural changes. We'll need to add some phases like a delay phase and a presentation phase with the stimuli flashes in front of the individual that's testing. But for the most part, right, it's as simple as just changing the things within each phase so that we're thinking about how the program works and structures. So since that was actually relatively quick, I'm going to try real quick. I've done this before, but I'm just going to go off on a whim and try and show you how I might make this a reversal learning task. And so let's go ahead and do that. So we're taking from the right or wrong, right? So this is what we have now. We have the right or wrong task where the red button is wrong and the green button is right. But maybe we want to do it so that at the end of a block of trials that flips, right? Let's give an example. Let's see, I forget how long these blocks are. It looks like they're probably 20 trials long. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, maybe they're 24 trials long. Sorry, I just got to check this out. Trials per block. Never mind, they're 20 trials long. I don't know why my trial type is so long. Anyways, so there's 20 trials per block. So maybe after 20 trials, we want to have it flip or something like that. Right, so there's a couple of different ways we could do that. And that's the beauty of coding in Python, right? You could do it one or two different ways. So let's think about, before we get into coding, let's think about sort of the structure of what we would maybe want to possibly do. So now what we have is we have the same structure of the program. We got the right or wrong. That's the same through and through. But we need to make it so that when the block refreshes, now the icons flip, right? So now stimulus 1 needs to become stimulus 2, and stimulus 2 needs to become stimulus 1, so that the red block is correct and the green block is not. Now, there's a couple of different ways to do this. One, we could make a different trial type, right? So right now, everything is within trial type equals 1, right? And you'll see this, every single one of our trial types are 1. But what we could do, and this is useful in some programs, is we could change it so that some of the trial types are 2. And then we just need to make it so that when a trial type equals 2, the red box is the correct answer. That's one way we could do it. The other option is we could have all trial types be the same. So we could always do trial type 1, and instead what we just simply do is we just modify the stimuli of, find it, when we create the stimuli, we just need to find a way to flip it. So watch, if I do this, if I take this and I make that a 2, and I make that a 1, so in line 252, I just changed the 2 and the 1, so that now the green stimuli is in the second position, 0, 1, 2, and the red box is now in the 0, 1th position. Now if I run it, pretty sure the red box will now be the correct one. See? So another simple way to do it, if I'm not trying to keep track of all these different complicated trial types, I can just leave the trial type equal to 1. And instead, I can find a way to just flip this, right? And so maybe that does involve using the trial type. But another way to do it is you could do it based off a block, right? So if self dot, let's do it real quick. So let's change this back. So that was what we originally had. But maybe let's just make an if loop, right? If loops are your friend. So let's say if self dot block. Let's see. Let me just make sure it's called the same thing. Yeah. So basically, I'm going to do this wrong here in a second. There's a quicker way to do this, but we'll just say if self dot block equals 1. Then maybe this is what we get, which is the normal green button being correct and red button being incorrect. And else if self dot block equals 2, then we go self dot stimuli equals, and then we just need to flip the 2 and the 1, right? So it's 2. And flip this to a 1, right? And so the way I'm going to show you this, let's see. I'm not going to sit here and run through 20 trials to show you that it works. But what I can do is go up here and change this self.block to a 2. So we'll leave it at 1 first. And the green button is correct. And the red button is incorrect. I'm going to close out of that. I don't have to wait for the timeout. But then if I go here and let's metaphorically say you just went through 20 trials, now your self.block is equal to 2. You can just do this, and I believe it should flip. So now the red one is correct, right? And the green one is incorrect. So just like that, in a very, very simple way, you can change it. So you don't even have to do all this sort of trial type stuff. You can just do one if else statement down here when you're creating the stimuli and just flip them, right? Now, obviously, this is not applicable beyond 2 blocks. So one way to do this is to get an operator. And so let me real quick look this up. There's a Python operator. I believe it's called a modulus. Let me just double check it. Sorry, I didn't prep for this at all. I wasn't going to do it this way, but I think this is a really important way to like know it. And so let's see. Yeah. So the modulus operator is just a percentage sign. And so, for example, if we do if self dot block is just a percentage sign. So if self dot block 1 equals 0, let's see. Sorry, 2 0, in which case this is going to be an odd block. So we'll just do this. Sorry, I'm doing this on the fly, but I'll explain it here in a second. And we'll change this to an else for all odd blocks. So, right, and then just for simplicity, we'll just to keep it consistent, we're going to go back and flip this. So it was consistent with what we said. So basically what this is saying, the modulus operator, let me just read exactly what it does so I don't misspeak. But essentially what it does is it returns a value after the division is performed, and it returns the remainder, right? So the percentage sign will return the remainder. So if I self.block divided by 2, what is my remainder, right? And so one way to check if you're trying to do even and odd blocks is to just use this modulus thing, right? So if self.block divided by 2 has 0 remainder, then it's an even block, and I want the red button to be correct and the green button to be incorrect. Otherwise, else, this is why I'm using an if-else statement, otherwise it must be an odd number, and therefore I want my green button to be correct and my red button to be incorrect. And so that's what this means right here. It's just a percentage sign. It's basically division and give me the remainder is what it's saying. So instead of doing divide, I'm doing modulus. And so now that applies to every even and every odd block. And so once again, we'll scroll back up here to the block. It is an odd block, right? So we should have the green button be correct. Let's see. It is. But if I go in here and I change this, let's say this is block number 9. Okay, block number 9. Now that's an odd block as well, but it's not block number 1. So the green block should still be correct. And the red block is still incorrect. But now let's say we've advanced further and further along, and I'm trying to close my program out, and maybe we're on block 12, right? So 12 is an even block, which means it should now switch back so that the red button is correct. Sure enough, the red button is correct, and the green button is incorrect. And so, as you can see, there are multiple ways you could have done it, and I'll show you how that works with the delay match to sample as well. One common way I like to do it is with the trial type array, and basically making these all 2s and basically making trial type, for this kind of session or this kind of session. But this was a really simple way to show you how the modulus operator works using even and odd blocks. Well, yeah. So I just want to do that, but there are other ways you could have done it, and there's no way that's necessarily wrong. There are some that are better and more efficient and requires you to change less things. Like I literally just added like 2 lines of code into that, whereas you would have had to do a lot of other stuff with the other one. But as you can see, like it doesn't matter. Like all of this is, most of what I know is self-taught anyway. So as long as you just figure it out, like as long as it works, and you can't find a sort of bug in the program. But even programs that people make for a living and make video games and stuff, they have bugs that people have to patch all the time. So just remember that. And yeah, I hope this was helpful, and it shows you that you can take a very simple system check program and you can make an actual program that the monkeys could use. And so a reversal learning task is something that you could very easily use. And so you could take this structure and you could make another reversal learning task. For example, and I'm not going to show you here, it would take me too long, but you could keep track of their performance. And so right now we have an aging project going on where we need to make it so that it only flips, the reversal learning task only flips after they've achieved 90% success within a block. And so only once they've gotten 9 out of 10 correct will it then flip. And so you can sort of add those if loops in And let me show you where you would do it, is you would do it right here in the new block, right? So you could add something, this is going to be super non-correct and it won't work, but you could do something like if, num correct equals equal or is equal to greater than or equal to 9, then we want to, flip it so that then that's when we would increase the block number, right? So that's only time block would plus equal 1, right? And that was basically saying that if they get 90% correct in one block, then the block increases to being an even number or an odd number, depending on what it was. So that obviously is not how it worked, but that's exactly where you could do it if you wanted to do something like that. Yeah, so I hope that was helpful, and let me know if you have any questions.